Let's look at a couple examples of hyperbolas that are centered at the origin. With these, we want to be able to maybe sketch a graph or write them in standard equation. We may want to also identify some of the key characteristics of that hyperbola. So for the first example here, I want to sketch the graph and write the standard equation of the hyperbola. If its foci are at the coordinates 0, -10, or at 0, +10, and the vertices are at 0, -8, and at 0, +8. And then I also want to write the equation of the asymptotes for the hyperbola. So let's start by plotting the coordinates for these foci and vertices. So we'll start by drawing an x and a y axis here. And I know the foci are at ±10. And I know the vertices are at ±8. Okay. So remember, when we see these conic graphs, the graph will always travel through the vertex and around the foci. Okay. For parabolas, there's only one focus, and for it, the graph always curves around the focus away from the directrix. For ellipses, there are two foci, and the foci are inside the ellipse. The ellipse curves around both of the foci. For hyperbolas, remember, hyperbolas have two curves. There's actually two separate individual curves that we have. They have to travel through the vertices, and they have to travel around, away from each other, but also around the foci. So if the foci are at 10 and -10, and the vertices are at 8 and -8, that means our graph has to curve upwards through the 8 and up and around the 0, 10. And then the other piece is going to curve downwards through the -8 and downwards around the -10. So we're going to have, in this case, we have a vertically oriented hyperbola. And the reason we need to know what the orientation is again, we have two different versions of our equation. Because it's vertical, we're going to have the y fraction minus the x fraction. So we're going to have the standard equation of y squared over a squared minus x squared over b squared, and that's equal to 1. So it looks very similar to an ellipse, but it's a subtraction instead of a plus. For the hyperbola, again, the vertical, because it's a vertical hyperbola, it's going to be the y fraction minus the x fraction. It's the y that's positive. If it was a horizontal ellipse or horizontal hyperbola, it would be the x fraction that's positive, so x minus the y. A is always with the positive fraction. So in order to write this graph, in order to write the equation for this graph, we need to find the a and the b value. Okay, well, a measures the distance from the center, which is at the origin. It measures the center to either vertex. And I know the vertices are at 8, ±8. So the value of A has to be 8. B, the value of B affects how wide the graph is, like how sharp or how flat the curves are. But it's not actually a value that we see clearly in the graph. It's going to be related to the asymptotes and sort of the width of the graph. But the C value, that's also related to our foci. So just like we've seen before, C is the value, the distance from the center to each focus point. And we know the foci are at ±10, so that means C has to be 10. So if we know A and we know C, how do we find B? Well, we have the equation c squared is equal to a squared plus b squared. Okay, that looks like the Pythagorean theorem, but it's connecting the a, the b, and the c values for our hyperbola, not necessarily a right triangle. So c we know is 10, so we're going to have 10 squared is equal to 8 squared plus b squared. So we're going to have 100 is equal to 64 plus b squared. 100 minus 64 is going to be 36. So 36 is b squared, which means b is 6. So we now know a is 8, b is 6, and c is 10. That's enough to write the equation. We already have the graph, so the equation is going to be y squared over 64 minus x squared over 36, and that's equal to 1. And again, the 64 is the a squared, the 36 is the b squared. All right, the last thing we need to look at is the asymptotes. So again, to imagine what these asymptotes look like, we could kind of think of there being a little box inside between the two curves of the hyperbola. Okay, the dimensions of this box are determined by a and b. So a, since this is a vertical ellipse, a tells me sort of the height of the box. It's actually going to be double that height. It's the length of the transverse axis. So this box has a height of 2a and a width of 2b. So that's where the b value comes in. It tells us the width of this rectangular box. So the height is 2a, the width is 2b. And then if we were to draw in the asymptotes, they would go through the opposite corners of the box, of the rectangle, and they would also pass through the center of this rectangle. Okay, and so we want to find the equations of the asymptotes here. Both of these asymptotes pass through the origin, so they're not going to have a y-intercept. So in this example, we really only need to find the slopes of the lines. Okay, and we can do that just by looking at the box. If you think of there being sort of a little right triangle here, from the center out to the top right corner of that box, and then down, we could create kind of a little right triangle. I know the rise of that line is A, and the run is B. So the slope for my asymptotes, the slope M is going to be rise over run. So M is A over B. And so I know A is 8. I know B is 6. So my slope, if I reduce that, is going to be 4/3. Technically, it's plus or minus 4/3. I want to actually write the equation of the lines, though. So remember, the equation of the line is y equals mx plus b. And because they both go through the origin, the b value is going to be 0. So the equation for my asymptotes is going to be y equals plus or minus 4/3 x. All right, let's look at another example. This time we're given the standard equation for the ellipse, or for the hyperbola, and we want to identify all of its key characteristics, so vertices, foci, length of the transverse axis, and the equations for the asymptotes. And then we want to sketch its graph. To do all of that, we need to first find the values for A, B, and C. So normally, and we can also identify whether it's a horizontal or vertical ellipse. So to figure out whether it's horizontal or vertical, look at the variable that's in the positive fraction. And so I have x minus, or x squared minus a y squared. The x is the positive fraction. So this is going to be a horizontal hyperbola. Okay, so because it's horizontal, that means the vertices and the foci are all horizontally related to each other. They're all along the horizontal line. And so A is now related to the major axis, which is horizontal. B is now the vertical height of that box, that rectangular box in the middle. A always goes with the positive fraction. So A is going to be 6 and B is going to be 3. Again, A squared is 36, B squared is 9. So we need to find C. And again, we know C squared is A squared plus B squared. So C squared is going to be 36 plus 9, which is 45. And 45 is a 9 times a 5. So C is going to be 3 square root of 5. So we have A, B, and C. And I know it's a horizontal ellipse. Let's figure out where is the center. Okay, since there's no h and k values, which we've seen with our other ellipses and um, parabolas, and we'll see it again here in a little bit with hyperbolas, the center is going to be at the origin. So center is 0, 0. So how do we find the vertices? How do we find the foci? How do we find the length of the transverse axis? And then how do we find the equation for our asymptotes? The vertices are always a distance of A from the center. Always. A distance of A from the center. And the center is at the origin. So A is 6. So I need to travel 6 units away from the origin. But in what direction? It's a horizontal hyperbola. So because it's a horizontal hyperbola, I want to travel a distance horizontally from the center. So my vertices are going to be 6 units to the left of the origin and 6 units to the right of the origin. So that's -6, 0 and +6, 0. Those are my vertices. The foci also travel the same direction. So it's a horizontal ellipse. We're going to travel horizontally from the center. Center is at the origin. So we're going to travel to the left and to the right a distance of 3√5. So we're going to have a -3 square root of 5, 0. And we're going to have a +3 square root of 5, 0. So those are the two foci. The length of the transverse axis is always 2a. And so since a is 6, the transverse axis is going to be 12. Let's start drawing the graph first, and then we'll come back and we'll look at the asymptotes. All right, so we know the center is at 0, 0. We know the vertices are at 6 and -6. So from 6 to -6, that is the value of A. So A is 6 to the left and 6 to the right. Okay, so that's the A value, which means the B value is vertical, and the B value is 3. So I need to go up 3 units, and I need to go down 3 units. And so I'm going to go from center, left and right 6, up and down 3, and that's going to create this box, this rectangular box for me. So this box is 6 units tall, 3 up and 3 down, and it's 12 units wide, 6 to the left and 6 to the right. And so I can then draw my asymptotes through the corners, the opposite corners of this rectangular box, and also through the center. Okay. And let's just go ahead and finish the graph while we're here. The graph has to go through the vertices, which are on the left and the right side of this box, and it has to then approach, it has to curve through the vertex and then approach the two asymptotes. So it's going to, from the right side, it's going to be it almost looks like a parabola, but it's not, opening to the right, and it should sort of curve out towards those two asymptotes, and then the one going through -6, 0, again, is going to open to the left and go close to those asymptotes. So that's what the graph of our hyperbola looks like. It is oriented horizontally, opening left and to the right. Okay. So again, what are the equations for the asymptotes? So let's start by looking at the slopes. Well, again, slope is rise over run. And so looking at this box, the rise is 3 and the run is 6. So the slope of the asymptotes is going to be 3 over 6, which is a half. And technically, it's plus or minus a half. One goes up and the other is decreasing. And both of those asymptotes cross through the origin. So if we think of this as y equals mx plus b, the y-intercept b is 0, right? Because they go through the origin. So I really just have y equals mx. And so my asymptotes are going to have the equation y equals plus or minus 1/2 x.